So 10.1 goes over square root functions. Again, we're not going to be graphing any of these. What you do need to know is what the parent function of the square root function looks like, which is what you see here in this coordinate plane. So any square root function that is just the square root of x, f of x is equal to the square root of x, looks like what you see on this coordinate plane. There will be different transformations happening to it. With those, you'll be describing those or identifying the transformations. You'll also be taking the domain of these functions. A square root, you cannot take the square root of a negative number. So anything that's underneath that radical sign has to be greater than or equal to 0. Has to. So when you are finding the domain, which is what we're going to be starting with, you're going to take whatever is underneath the radical. You're not going to pay attention to anything else, just what's underneath the radical. And you're going to set that greater than or equal to 0, and you're going to solve for the variable. Other than that, that's all you got to do in order to find the domain at least. So if we look at example 1, it tells us to describe the domain of each function. Example A gives us f of x is equal to 3 times the square root of x minus 5. Again, we're not going to worry about anything else other than what's under the radical. Under the radical, you have that x minus 5. So you're going to take x minus 5, set it greater than or equal to 0, move your 5 over by adding it to both sides, and you get that x is greater than or equal to 5. So your domain is x is greater than or equal to 5. For example B, we're given f of x is equal to 10 square root x. The only part that's underneath that radical is the square root, that is the radical is the square root of x. So x gets set greater than or equal to 0. We don't have to do anything with that, so automatically our domain is just that x is greater than or equal to 0. For example C, we have y is equal to the square root of 2x plus 7. Now that plus 7 is not underneath the radical. The only part that's underneath the radical is the 2x. So we're going to take 2x, set it to be greater than or equal to 0, and solve for x. So we divide each side by that 2 to get x by itself, and we have x is greater than or equal to 0, since 0 divided by anything is 0. For example D, we have h of x is equal to the square root of negative x plus 1. So that entire thing underneath the radical, that negative x plus 1, gets set greater than or equal to 0. First thing we're going to do is we're going to subtract the 1 from each side. We have negative x is greater than or equal to negative 1. From here, we divide each side by the negative 1. Remember, when you divide each side by a negative in an inequality, you switch the inequality sign. So we just have x is less than or equal to negative 1 divided by negative 1 is a positive 1. So our domain is x is greater than or equal to 1. The next part of your lesson tells you to graph each of these functions. However, we are not graphing these functions. We are going to be stating the transformations. So a couple things that I want to remind you of. If you have something like f of x is equal to a negative, a number, the square root of a number, or a negative, here, let's do this differently. A negative, a number, x plus or minus a number, plus or minus a number outside. These mean different transformations. So this negative here is a reflection, and it reflects vertically, so it would reflect across the x-axis. This number directly in front of your radical is a vertical stretch or a vertical compression. The negative underneath the radical means that we reflect horizontally, so that means we reflect across the y-axis. The number in front of x under the radical would represent a horizontal stretch or compression. The plus or minus underneath the radical means we're going left or right. And the plus or minus after the radical outside means we're going up or down. If I were you, I would write this down because this will help you. You also have a table later on in your notes that gives you these transformations as well. They're not all put together in the same function, but they are given to you in a table later on in your notes. For these examples, for example 2, we're just going to be telling the transformations, stating the transformations that are going on. We're not going to be graphing them at all. So if we look at example 2a, we are given f of x is equal to the square root of x plus 3. That plus 3 is after the radical, outside the radical. So we're going up 3 units. Again, this is from, or the first time you saw this was from chapter 8, when we were dealing with those quadratic functions, those x squared functions. For example B, we're given g of x is equal to the square root of x minus 4. That minus 4 after the square root means that we're going down 4 units. So you see here that if it's plus a number after the radical or minus a number after the radical, it's going up or down. Plus a number means you're going up that many units. Minus a number means you're going down that many units. Our next example, we are given y is equal to the square root of x plus 5. This plus 5 is under the radical, so it's happening horizontally. We want to think opposite of what we see. So opposite would be a negative, which means we would go to the left 5 units. For example D, we have n of x is equal to 5 times the square root of x. This 5 in front of the radical just means that we have a vertical stretch or a vertical compression. To tell whether or not we have a stretch or compression vertically, if the number is between 0 and 1, then it's going to be a vertical compression. This number, however, is greater than 1, so when we have a number greater than 1 for a vertical stretch or compression, it's going to be a stretch by a factor of whatever that number is. So this is a vertical stretch by a factor of 5. Our next examples for this part are going to be focusing on these transformations you see from this table. This is the table that I was explaining to you before that tells you all of your different transformations that's later on in your lesson. So with these, we look at each of these transformations separately. We have a horizontal translation, meaning right or left, if the plus number or minus number is underneath the radical. If it's something like the square root of x minus 2, that means we're going to the right 2 units. If it's something like the square root of x plus 3, we're going to the left 3 units. We also have vertical translations up and down. If the number is after the radical, so it's plus a number minus number, and after the radical. If it's plus a number, so like the square root of x plus 7, we're going up 7 units. If it's something like the square root of x minus 1, we're going down 1 unit. We also have reflections with these functions. If you have a negative underneath the radical in front of x, we're reflecting across the y-axis. Remember, it's happening horizontally, side to side. So if you're reflecting side to side, the only axis that it could cross would be the y-axis. If you have a negative in front of the radical, that means that you have a reflection across the x-axis, and it would be reflecting vertically up and down, so it would go across the x-axis. Now your stretches and compressions. Your textbook likes to use this word shrink. It means compression. Please use the word compression instead. you have horizontal stretches and compressions. That is when your number is underneath the radical in front of x. It's the coefficient of x. You are going to take the reciprocal of these numbers. So like if you look at to the right here under horizontal stretch or compression, you are given g of x is equal to the square root of 3x. Take the reciprocal of the 3. It's 1/3. That tells you whether or not you have a stretch or compression. If it's less than 1, greater than 0, you have a horizontal stretch. So, oh my gosh. You have the 3. You take the square root, the inverse of it, it's 1/3. The 1/3 is a number between 0 and 1. So you have a horizontal compression by a factor of the reciprocal, which is 1/3. If you have something like the bottom one where it's g of x is equal to the square root of 1/2 x, take the reciprocal of the 1/2, it's 2. That would give you a horizontal stretch because the 2 is greater than 1 by a factor of 2. And their factors are always going to be the reciprocal of these horizontal stretches and compressions. That is not the same for your vertical stretches and compressions. Your vertical stretch or compression is the number in front of the radical, directly in front of the radical. It is what you see. So if you have something like g of x is equal to 4 times the square root of x, that's a vertical stretch by a factor of 4. You're not taking the reciprocal of the number, you're just using the number as it is. If it's greater than 1, it's a vertical stretch. If it's between 0 and 1, it's a vertical compression. For g of x is equal to 1/5 times the square root of x, that 1/5 is what you're using to tell whether or not you have a stretch or compression. That 1/5 is between 0 and 1, so you have a vertical compression by a factor of 1/5. The only ones you're taking the reciprocals of are the horizontal stretches or compression, so if it's underneath the radical in front of x. For the next part of this lesson, we're still taking the transformations and just identifying those transformations. For example A, we're given g of x is equal to the square root of x minus 2. That x minus 2 is what's underneath the radical. That minus 2 is what you're looking at. It's underneath the radical, so it's happening horizontally. It's after the x, so you're going either right or left. The sign in front of it is negative. Think opposite positive. Positive would be to the right on the number line. So we're going right 2 units. For example B, we have h of x is equal to the square root of 1/4 x. That 1/4 is the coefficient of x underneath the radical. So take the reciprocal of it. Reciprocal is 4. 4 is a number greater than 1. So we have a horizontal stretch by a factor of 4. For example C, we have g of x is equal to the square root of x minus 6. For this one, that minus 6 is after the radical, so it's happening vertically. We're going down 6 units. For example D, we have m of x is equal to negative 3 square root x. We have 2 different transformations here. One that's the negative, one that's the 3. The negative in front of the 3 represents a reflection. Now it's happening vertically, so the only axis that you can reflect across vertically would be the x-axis. So it's a reflection across the x-axis. Next, you have that 3. The 3 is in front of the square root of x, so that's a vertical stretch because it's greater than 1 by a factor of 3. For the next part of our lessons, we're taking multiple transformations within the same function and identifying all of the transformations. For example, for A, we are given g of x is equal to negative 2 square root x minus 3 minus 2. So I'm just going to rewrite this as g of x is equal to the negative 2 square root x minus 3 minus 2. All right, so first thing that we are going to look at is the negative. That's a reflection. It's happening vertically, so that's a reflection across the x-axis. Next we have the 2. 2 is in front of the radical, so it is how you see it. That gives us a vertical stretch. By a factor of 2. Next is that minus 3 under the radical. You want to think opposite. So instead of it going to the left 3, we're going to the right 3 units. And lastly, we have that minus 2. So that means we're going down 2 units. Our last example, we are given g of x is equal to 1/2 times the square root of x plus 4 plus 1. So I'm just going to rewrite this down here so that way it's easier for us to look at. 1/2 square root x plus 4 plus 1. All right, so first thing we're going to look at is the 1/2. The 1/2 is in front of the radical, so we are going to have a vertical compression because it's less than 1 but greater than 0 by a factor of 1/2. Next is that plus 4 underneath the radical. Think opposite, that would be to the left 4 units. And lastly, we have that plus 1 after the radical, so we're going up 1 unit.